Welcome everybody to the June 14th, 2016 meeting of the Mississippi PowerShell User Group. Tonight we're pleased to have Microsoft MVP, consultant, and author Robert Cain presenting about using Pester with PowerShell for test-driven development and for uncovering bugs. Welcome, Robert.
Good afternoon, or I should say good evening now at this point. So, welcome everybody. We are here tonight to talk about Pester. So, a few housekeeping slides. Let's see. Just a little about me. I live over next door to y'all. I'm in Birmingham. Microsoft MVP. I own my own company, Arcane Training and Consulting. Most of the work I do is through Pluralsight. Through Pluralsight, I produce all kind of training videos, and so I've got 10 out now, and my 11th video should be hitting this week, and it is on Pester. So what you're going to see tonight is a subset of that video course. If you've got a Pluralsight subscription, then you'll be able to see it. We'll show it to you in a little bit. If you don't have a Pluralsight subscription, just shoot me an email to free@arcanetc.com, and we'll be glad to send you a code, give you a 30-day trial so you can go watch the longer video. And this is good for anybody watching this live or if you're watching this on the recording. I also do work through Linchpin People. I'm a teammate there. For those of you who are in the SQL Server community, you'll have heard of Linchpin People, group of kind of independent companies that merge together under the Linchpin People umbrella. I've co-authored 4 books and am working on the 5th. I've got that weird genetic defect that I love speaking, so I've spoken at SQL Pass, SQL Saturdays, lots of different places. I'm on Twitter as Arcane Code, and that's also my blog, as you can see. I'll be at a couple of events upcoming. I'll be in Chattanooga June 25th for the Chattanooga SQL Saturday, where I'm doing a PowerShell session. Mike told me just now that I've been accepted for the Baton Rouge SQL Saturday, so I'll be there in Baton Rouge on August the 6th. And then here in Birmingham, keep an eye out. We're going to be doing a big event in August called Dev Data Day. We are going to have a PowerShell track. We're also going to have 3 SQL tracks, 3 .NET tracks, and a professional development track. So lots of good stuff there. That'll be free. I'm also doing the day before, on August 19th, a pre-con on PowerShell and SQL Server. So we'll be talking in depth, kind of more geared toward the first half of the day for the PowerShell beginner. And then the latter half of the day, we're going to talk about how to use PowerShell in conjunction with SQL Server. So some really good stuff coming up there. Wow, that's the end of the slide. Sorry, guys. I know you probably love slides, but since this isn't a PowerPoint user group, we'll actually go look at some PowerShell. So we're actually here to talk about Pester. Now, Pester is an open source testing tool. Now, I guess the first question we should really answer is, where do you get it from? So I really should have jumped over here to the Internet Explorer. You can find Pester through the GitHub site for it. So it's just github.com/pester/pester, and you can see they have all the different information here, the files. You can download this as a module, and if you're on PowerShell version 3 or 4, you'll have to go download this manually and install it. If you are on PowerShell 5, there is a much easier way. Pester is in the package management framework, or as they call it, OneGit. All you have to do is import that package management module, and if you're not familiar with it, it is a repository through which you can easily get modules, download them, and keep them updated. So to install Pester, all you have to do is use install-module, give it Pester. Now, the reason you might want to do force, Pester is an open source tool, but it actually ships with Windows 10, believe it or not. The thing is, the version that shipped with Windows 10 was version 3.3.5. Pester is now up to version 3.4, and as I understand it, version 4 of Pester should be released in the immediate future, so be aware of that. So what you can do is just use install module Pester, and it will install Pester on your system. After that, all you have to do is call update module whenever you hear about an update, and it will then update Pester on your system. So if you're running PowerShell 5, you've got it made. This makes it real easy. If you're not running 5, think about it. Also be aware that the PowerShell team loved Pester so much that they have written Pester tests for most of the PowerShell code that they have. So just be aware that that was probably a huge undertaking, but wow, what a ringing endorsement for Pester that they actually went to that much effort. So I'm sure you're wondering at this point, how do I actually, now that I've got it installed, how do I actually use it? What do tests in Pester look like? Well, let's go look at this. Pester tests at its very basic component consist of two parts. The first is describe. The describe acts as kind of the home for all of your little tests that you want to employ. Now you'll note we have the keyword describe, and what you may be surprised to find out is describe is actually nothing more than a PowerShell function. If you go into that Pester module, you can actually see the function, you can read its definition, and unlike most modules though, they chose not to use the verb-noun naming syntax. The reason for that is they wanted Pester to be a domain-driven language, or as they call it, and with domain-driven languages, you'll typically want to use commands that are more descriptive of the work going on. And so describe actually accomplishes that. It describes a series of tests. Well, the first parameter we're passing into the describe function is what we want to name it. So here I just called it a dirt simple test. Then we have an opening squiggly brace. This denotes the beginning of a script block. You can see down here at the bottom, here is my closing script block. Note, it is important that your squiggly brace be on the same line as the describe. I know a lot of people, and me for one, when they're typing, say, a for each loop or a function, will want to put the squiggly braces down here on the next line so they line up. Well, remember, I said describe was a function, so this script block is actually a parameter that we are passing into the describe function. So that squiggly brace has to be here. Alternatively, if you really wanted it on the next line, you could use a line continuation character out here and then put it on the next line. But that's just kind of a lot of effort as far as I'm concerned, so I just stick it on the same line. So now that I've got my describe block set up, I'm going to come down here and I'm actually going to construct a test. Tests use the keyword it. After the word it, we have a description of what it does. So in this case, my test, it should be true. I then have my squiggly brace, and then the first thing I have is a condition. This condition will be evaluated and then piped in here, note my pipe character, to another function called should. Should is what actually examines the result that is piped into it to determine if a test passes or not. Should has several versions. The most basic of these is should be. With should be, you then give it a value that the information coming in should be. So in this case, it should be true. Now, if I go run this, well, that's a good question. How do I actually run this? Let me comment a few things out here. We'll just go down here. I'll comment out the rest of the code. To run a Pester test, you can come over and you would simply use invoke-pester, and then you can give it the name of a file. So I'm going to come here and execute this, and it's going to run the test in here. So you can see what it looks like. Describing, and then we have the name, a dirt simple test, and we have should be true. So we see all in green means that it block test passed. We then have how long it took to complete all of the tests, and then we have a summary. Passed 1, failed 0, skipped 0, pending 0, and inconclusive. Now the fact that it needs to put these totals in here would infer that I can have multiple it blocks within a describe, and you most certainly can, and we'll see examples of that momentarily. So if I come back over here, let's look at the next thing that you can do with a test. Let me move this down. So the next variation on should is should exist. You know, a lot of times you're working with code that generates a file. So one of your tests should be to simply make sure that that file exists. And actually this should be named should exist. Must have copied something the other day. There we go. So it should exist. We then take the name of a file, and then at the end of the file name, we simply pipe it to should exist. And you know, instead of be, we have the keyword exist. So if I want to go run this test, we'll simply come back over here. And now we can see describing should exist test, and should exist came out as true. We got a nice green light, and we get passed of 2. So what happens, let's say, if that file doesn't exist? I'm going to change the file name here, and we're just going to stick, maybe a couple of R's after it, and we'll save it, and then we'll run it again so that you can actually see what an error looks like. So here you can see now the should exist comes out in big red, and we have a minus sign indicating that this failed, and we can see expected, and we see that the file name was expected to exist, and that it failed in the should exist at the script block, line 13, and we see that the file name, this is not the file of the test, or excuse me, this was not the file that was being tested, this was the file that had the error in it. So we can see in our totals, 1 passed and 1 failed. Great. So now we're starting to build up a few tests here. Let me go fix this for the next time. Now, we can actually expand on this. You can see that we can have our should exist, and we can actually use variables in here. So here is my sum file, and this is just the name of the file that we're looking for. And in my it block, I'm actually using the variable within the it block's first parameter. Some files should exist. So this is a very powerful technique, as we'll see, because now I can actually construct it blocks within a loop, whereas I'm using variables. So if I had an array of 15 files that I wanted to see exist, I could just see this as using the name of the current item in the array, and I can include it not only in the it, and I can also use it here in the some files should exist. And of course, if we run this, it's going to look pretty much like what we've seen before. Should exist, and it tells me here you can see where it took C:\Pester course blah 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 should exist. So now I'm actually getting back some decent information here within my test output. Now, if you have a lot of tests going on in your describe block, it can be useful to organize those tests into multiple, subtests. So let me show you this. We'll just get rid of that as well. Here's a little bit longer describe block. So we're going to do grouping using a new keyword called context. So I have my describe, and then I have the keyword context. And then I have the name for the context and the opening squiggly brace for the script block. You can see down here is the closing script block, and then everything in here is part of this context block. So I've got a should be true, then a should be false, and then down here we've got our second context block, and you'll note we're introducing a new variant on should. Should, in addition to the positive ways of looking at things, also has a not version. So should not be true. There's also a should not exist. These are all things, variations that you can use. So let's actually go run this. And, let's see. Oh, got to save it. It helps if you actually save your demo before you actually execute it. So, word to the wise kids. So now you can see the output of our context. You can see we have the describe block. Then within the describe block, we've got context test group 1 and its tests, context test group 2 and its tests. We then pass all 7 of these, so E18. Okay. So now we've seen just a few basics of how PowerShell uses Pester, and really this is the core to all that you need to know for Pester. Using these few concepts, the describe block, the context, and the it, you can actually accomplish a lot of testing. So let's actually go over here, and I'm going to use, I'm sure you've seen Mike show off the Sapient PowerShell Studio, and I'm going to use this because it lets me switch back and forth between these files easily. So here I have a module. This is part of the course I did for Pluralsight, and in that course what I'm doing is I have a fictional company called Podcast Site. Podcast Site acts as an aggregator for podcasts. And so each podcast has its own PowerShell module to get the data, read the RSS feed for that podcast, to download the images and download the files. And then it also has the ability to write out an XML list that has all the information that Podcast Site wants. It also will create an HTML web page. So pretty cool stuff. Let's go look at this. And the module is pretty straightforward. We just have the module to process. This is the manifest file, the GUID, all that kind of stuff. Kind of the standard things you want. And then we've got a PowerShell module. Yeah, I'm not sure why I put the SQL PS in here, but anyway, we have our functions that get executed by the module. Now, what I did was each function got put into its own module. I then have 2 export module members where I'm exporting a get podcast data and the get no agenda. And then I have several module members down here that during development you might want to uncomment these, but for that production module, according to the fictional set of requirements that I show in the Pluralsight course, they have, these are not to be made public. These are for internal use only. That's why they're commented out. Okay, so how would I go about testing my module? What I want to do is to create a test that makes sure I have all of my module members, that I have all of the functions available, and so forth. So let's come down here, and I've created a file called podcast no agenda module .tests.ps1. Pester has the ability to run tests in multiple files at the same time. All you have to do is navigate to a folder, type in invoke-pester, and it will go find all of the files that end with .tests.ps1, and it will execute the code in them. So let's actually go look at the code for the module. So the first thing I do is I use a technique called, there's a built-in variable called myInvocation that says where was I executed from, and it has an object called myCommand, which has a property called path. And so this says, this has the full file name, which would be podcast-noagenda.module.tests.ps1. And so split path basically pulls off the path part and discards the file name. And so we're going to do this at the top of each one of our tests just to get the current location where the tests are being run from. I then come down here, and in a variable, I put the name of the module that I'm testing. The reason I do that is because each one of these has, or I guess for every time you want to test a module, the tests are going to be pretty similar. So by putting this in a variable name, I can easily reuse a lot of the code in here. Now, here is a new little thing we haven't seen. Beside the describe block, we have this dash tags parameter, and you can see I am passing in two tags, unit and acceptance. This is something we'll go into more later, but with invoke Pester, you can actually say, I only want you to run tests that have this tag. So I can only run my unit tests, or I could only run my acceptance tests. Now, these are words I just made up. We could have named them, I don't know, Mike and Marco and Ron. You know, you can name these anything you want to. Most people, though, will either use unit, acceptance, or they might throw in integration if they had something special for integration. Then I have my name, and you'll see where I'm using the variable module tests in my opening script block. I then create a context block for the module setup. I then create my first test where I'm saying it has the root module, and we've said, well, this module should be named podcast-noagenda.psm1. So we're going to make sure that that file actually exists. So here you can see I use the here combined with the module name to construct the file name, and then I pipe it into should, and you can see I'm using the should exist version of this test. So once we validated that we have the PSN1 file, we now want to check to see if it has the PSD1 file associated with it. So we're going to do another test. And here, we're actually going to put two different checks within the same test. So for this particular test, it has the manifest file of $module.psm1. Both conditions within here must be true. The first one, module PSD1 should exist. And then we're going to use another variation we haven't seen yet. We're going to use should contain. So what should contain does is it says the file name being piped in should contain this text. And we put the text that we want, and we're looking for the module name.psm1. And you probably guessed that already from just looking at the name, should contain. And again, that is why we're using a domain-driven language, is so that people who may not be as technical can look at this and get very quickly up to speed and go, well, okay, should exist. That's obvious. The file being piped in should exist. Should contain, same thing. Should have that. So with the way the should works, it makes it very easy to understand the tests. So the next thing we're going to look for is, as part of the requirements, each function has to be in its own individual PS1 file. So this is going to make sure that we have at least some PS1. We're not checking for specific PS1 files, but we're going to make sure just some function-PSM1 files exist. And note, we can use the wildcard with should exist. Next thing we're going to do is validate that our module, our PSM1 file, is valid PowerShell code. And this is a pretty cool technique when you're doing these tests, because it will simply go in and make sure that all your syntax is correct. And this can help you not just with the module, but when we go see a function test, so that you can actually validate your function doesn't have any syntax errors. So we simply give it an it name. And then what we're going to do is we're going to load the content of the file into a variable called PS_file. And you can see we're using get-content. And what we're going to do is we're going to call a .NET library called System Management Automation.psparser. I know everybody says, well, PowerShell is everything's object-based and it's all based on .NET. Well, the specific set of libraries it's based on is system.management.automation. And so because of that, you can actually take advantage of many of the functions in the automation library. And one of the things we're going to do is access the PSParser class. So if you're not familiar with this, if you were to actually go into the online documentation, you could actually find the System Management Automation PSParser class, and it has something called the tokenize method. Tokenize will actually take the file that you're coming in. This actually has to have the contents of the file, and it will return a list of errors. Now, we address it in this way because this is what is called a static function. It simply is a function that you can call without having to create a new instance of the PSParser class. So to call a static function inside a .NET class, we simply use : and then the name of the function that we're calling. You'll note with the errors, I'm having to use the ref. That basically says, hey, it is okay for this function to update the $errors variable that is part of my PowerShell. And you'll note I had to initialize it. When you're interfacing with the .NET framework, a lot of times it doesn't like, if the variable doesn't exist, it will give it heartburn. So that's why we simply set errors equal to null, so that PowerShell will actually have an error that this thing can talk back to. And what this does is it returns a collection of errors. Well, collections have a .count property, so if nothing happened, the count should be 0. So pretty cool test, and you can use this for a lot of different stuff. And this concludes the module setup context. So now now that we validated the module is okay, we're going to come down and we're going to look to make sure the functions are okay. Now at this point, we're not testing the functions themselves. In other words, do the functions do what we said they're going to do? We're simply validating things like, does the function exist? Is the code in it valid? And so forth. So here you can see I have loaded up my functions into an array. Remember a minute ago I said this is one of the cool things you could do because of the way you can use variables. So I got an array of my function names. I fall into a for each loop. I then set up a context block, and yes, within the context block I set up $function as the name of the function. So what this is going to do is it's going to generate a context block for each function name in my array. You've seen this a moment ago. We have the should exist. Next thing I'm doing is I'm checking to see, does it have a help block? Now, this is kind of a loose test because what I'm looking at is, does it have the opening and closing help block? But at least it's a place to start. And I'm making sure that both of those exist. I then come down here and I have several its to test, does the help have a synopsis section? And you can see I'm checking, does it contain .synopsis, .description, and .example? Now, I could have put all three of these checks within the same it block. It just says it has the required help items. So you can do it either way. The advantage to breaking it out like this is that if somebody included a synopsis, but they left out the description, by separating it out, I get a very exact error message. I know exactly what was missing. Conversely, if they were all three lumped together, then I would have to go look and see, well, okay, which was it that was missing? Was it the synopsis, was it the description, or was it the example? So, so you don't want to get too, I guess, all-inclusive with your it blocks, but at the same time, you don't have to go too granular. So you can see here, I think we've struck a nice balance. In this first one, we're checking for the opening and closing, and that's okay. And then down here, we've broken it out into separate parts. Now, the next thing I want is that part of the requirement said that all functions have to be advanced functions. So for an advanced function, I know that I have to have the keyword function, commandlet binding, and param, because those are, according to my requirements, what contains an advanced function. So, and I did it like this just to kind of show you the flip side. So now, if any one of these fails, this particular test. So again, we see another way of doing it. I had another requirement that I made up that said all functions have to have at least one right dash verbose block, just to say, hey, I'm here. I then repeat my is valid PowerShell code, just to make sure that each function has valid PowerShell code in it. I then come to another context block, and in this context block, we've said all functions must have a test. So I'm going to look for the function name .tests should exist. So if I actually want to go run this, I've actually set up a simple little what we call test harness. And so for my test harness, I'm simply going to set my test folder and set the location so I'm actually there. And then I'm going to use invoke-pester, and I'm going to pass in the name of the individual file that I want to test. So let me execute this. And we'll make this a little bit bigger so you can actually see it. So we can see that this wound up generating 76 tests, and that all of them passed. And that's really the power, I think, of Pester and the ability to create dynamic tests. If I were to come back at a later point and say, okay, management has requested I update this module to perhaps add another function to it, all I have to do is come in here to my test, and I simply go to the part of the test where I list my array of functions, and I just type in the new function name. So dynamic testing is a very powerful feature that you can implement. Okay, so that was our first test, and here what we've done is we've actually tested the module, by which I mean we've tested the module contains everything it should. Now what I'd like to do is to create a test to make sure the functions do what they're supposed to do. So let's look at our first test. Let me just show you the first thing we're testing, and that function is get podcast data. And what this simply does is it calls invoke-rest method, and I pass in the RSS address for the no agenda show. It then goes in there, and for each object that brought back in the RSS feed, I go clean up the data and place it into a custom object. Once I have accumulated all the custom objects, I simply return it. So, pretty basic. Let me actually go look at the tests now that we created for this. So, like before, we start with our here to get the current location in my system. But notice this line, get-module, podcast no agenda, pipe to remove module. What in the world? Well, if the podcast no agenda module is loaded into memory, we have no idea where it was loaded from. In other words, I have all the code for this in the current folder, but if somebody had deployed this to their system, an older version, they may have loaded into memory the older version of Podcast No Agenda out of their user Windows PowerShell modules folder. So what we want to do is first unload the module if it is indeed loaded. What I then want to do is import the module from my current folder. So import module, and you'll notice I'm using that here variable, which is the current location, and then I give it the name of the PSM1 file. And by doing so, I know that I'm always testing the code that is in the current folder. Now, most typically, you're going to have your module or code that you're testing in the same folder as the tests. If you choose to keep your tests in a separate folder, then obviously you'll simply need to accommodate that here by setting the here to wherever you have the module at, as opposed to where the tests of the module are. So just be aware of that. So we fall down to our describe block, get podcast data tests, and on the very first line, I call the function, get podcast data, and then it loads that data into RSS data, and now I'm going to query the RSS data for each podcast in the return data. I'm going to say context has the correct properties, and I have an array that I'm looking for the properties for. I also know that the RSS feed for No Agenda has the most current 15 episodes. So I should have 15 rows loaded into RSS data. Now I'm going to come in here and I'm going to do some spot checks on the data. So for each row, I'm going to come in here. I'm going to make sure the image URL is a JPEG. I'm going to make sure the audio ends with MP3. Going to make sure the show URL contains no agenda notes, and make sure the hosts contain their proper names. So now you can see that I have tests set up to validate that the function works, that it brings back the data that I'm expecting it to bring back. If I want to go execute this, I'll simply come to my test harness. And you can see this is why the test harness comes in useful, because it lets me simply highlight it and run the individual tests that I want to run. So we'll execute this, and this should take just a second. It has to actually go out to the web and go get that information. So here is the information. And we actually saw a little bit of red. If I come up here, we see that these should contain no agenda notes. Apparently they have something with their feed that it didn't have the notes in there correctly. So this tells me that I need to actually go look at either the feed or look at the code that loads it into the feed. So I know I've got an issue somewhere. And this shows you that not only can you test to make sure your function's correct, but if you know your function's been working just fine, what you could actually do is then turn this code into something that, okay, each time they come out with a new episode of No Agenda, first thing I'm going to do is run this code to make sure they haven't changed anything in the feed that's going to mess my code up downstream. So you can actually take these tests and make it part of your regular production cycle. So another great use for Pester. All right, so that was pretty straightforward. You know, we're just checking for data. We're making sure, again, you saw basically all we did was we used a whole bunch of contains blocks looking for should be true to see if certain values exist. Here we're also using the podcast object image URL property. We're using the dotnet string ends with to make sure it ends with the correct thing. Or we're using the dotnet contains to make sure that it contains a certain item. So pretty straightforward, you know, pretty cool stuff. Let's go look at something a little more complex now. Let's actually go look at something that will go download the images associated with the podcast. One of the reasons I like using this particular podcast for my demo is that each episode they have a new piece of artwork associated with it. So I'm going to come over here, and first we're going to open up the function just so I can show you what it looks like. And we have a required help, and we have our commandlet binding. And here, what we do is we pass in that same RSS data, you know, that RSS data function we just called. That data gets passed into here, and then we have an output path folder which has a default value. We have our required write verbose statement. And then what we do is we simply fall into a loop that says for each podcast that was contained in our RSS data, we're going to get the first thing we're going to do is take the image URL and we're going to split it on the slash, okay? So that, and then we're going to get the last item in that array that the split returns so that we isolate just the file name of the image. And then we're going to create another variable called out file name where we're going to take our output path folder, combine it with the image, and this basically says, hey, here is the file name and path that I want you to download to. We then use test path to see if the file exists. If it exists, we're just going to skip it. There's no reason to download it again because we already have it. If it doesn't exist, we're going to use invoke-web request. We're going to download that image URL, and invoke-web request has an out file parameter where we can simply say, here's the file name I want you to download that to. All right? And so, and this other thing we're doing here is to let users know that we actually downloaded something, we write that image file name out the pipeline output. So how do we test this? Well, let's go over here to get podcast image tests. And this test is going to get really kind of complicated. We're getting the current path. I'm not quite sure. I think that was here from another demo I did. So we'll just skip over that. But we have the get module, the import module. So now we fall in. You're going to see this in module scope. Okay, that's a new one. And the reason we need in module scope is because down here in our describe block, when I scroll down here, way down past all my XML data, and we'll explain this in just a moment. When I actually call my function, where did it go? Parameter loops. All right, we'll find it here in just a second. But when I actually call the function, if you recall from the function, I did not export the module member of get podcast image. If I come back over here to my module, go close a couple of these. I guess I closed it, but if the module PSD1 file, you'll notice that, the get podcast image is not exported. So that means if I just tried to call get podcast image, Pester would return an error. It says, I can't find that function. It doesn't exist. So to fix that, the folks who created Pester came up with this really cool concept called in-module scope. And so you can see what in-module scope does is it's going to change the scope from the current executing file to the scope of the module. Now, everything that I'm doing in the module, I have access to its functions, its variables, the whole 9 yards. So after my in-module scope, I fall down here to my describe block. With my describe block, I have my unit test first. This is the point where we start getting into the differences between unit testing and acceptance testing. Unit testing is something that the developer typically does, and he wants to construct the test in such a way that he isolates it from the other tests that are going on. In other words, he doesn't really want to call any of the other functions. So to do that, the first thing I want to do is not call get RSS data. I actually want to create that data on the fly and pass it into the get podcast image tests. That way, I know I am not, executing the get RSS data. If I ran across, let's say, an issue that something failed, I'll know that the bug is not in get RSS data. It must be either in my test or it is within the get podcast image function. So that's what this mock RSS data is. And I explain in the comments how to actually create this. So if you get the source code from me, or if you watch the video that I did for Pluralsight, it actually goes into some explanation of how this came from. But essentially, I created this data using export CLI XML. And I took the data from get RSS data, passed it in there, and then opened up the output from it, pasted it here, and you can see all of the shows. And then to get it back into memory, I used another library called PS Serializer. That PS Serializer class has something called deserialize as list. And this is essentially what import CLI XML does under the hood, is it reads the data in and then does deserialize as list to turn our mock data back into a real object. So once I've got this quote-unquote bogus or mock data in memory, I then just go through into here to a loop. Now, I actually have to test this twice. The first test I have to do is passing in RSS data to get podcast image as if it were a parameter. Then, because this is a pipeline-enabled function, I need to pass it in using the pipeline function. Well, all of the other code for the test is going to be the same. So rather than having to do two separate describe blocks or two separate contexts, what I just did was put it in a loop. One's parameter and one's pipeline. So what's going to happen is down here in the if $loop equals parameter, I'm going to call get podcast image, and I'm going to pass in RSS data as a parameter. If the loop is not equal to parameter, I call it using the pipeline. Okay? So what's all this stuff in between? Well, obviously, if we're downloading files, we've got to have some place to put them. Well, part of unit testing is you want to affect your environment as little as possible. So we don't actually want to put those files somewhere that they're going to have to hang around or that they might get left over. For example, let's say I download the file, but the power goes out in your building. So halfway through the test, it's downloaded the files, but, you've got them stuck out there because your test never cleaned up after itself. Well, the next time you run the tests, maybe it can't connect to the internet, but it still sees the files are out there because they were left over from the time before. So to handle all of this stuff, the folks who created Pester created a cool variable called test drive. What test drive does is it goes out and creates a temporary folder in your user's temporary area. And it takes that temporary folder and makes it look like a drive letter. So here I call test drive to actually go create this thing, and then I can then use it as if it were a drive letter. So what I did was I created a test drive folder that I combined the path to test drive, and then I used \, and then I used my loop variable. So it's going to be whatever the test drive folder is by parameter, and then after parameter we'll have, pipeline. Now I actually need to create that folder, and that's what new item does for me. New item test drive folder, and then the item type of directory. So I know that I have to call my function 2 different times. I've created a folder to put the files in. If you recall, inside of my function, I am calling the commandlet test path. Now, since this is a built-in PowerShell function, you could probably let it call test path without any repercussions. But what if test path wasn't a built-in commandlet? What if this was another function within your code? You would want to isolate this. So I know that test path is going to check to see if a file exists. Well, because we've just created a folder, we know it's going to get empty. So what Pester has is a concept called mocking. I can say mock, and I can say the name of any commandlet or function. Now here I'm actually doing this to a built-in PowerShell commandlet. And what we're doing is we're saying when you go to run test path, no matter where it's called from, within your, I want you to, instead of running test path, I want you to run the code within this squiggly braces. And of course, we know that we can just return false, but you can make this as complex as you need it to be. And there are some examples in other places in the code where I've done just that. Okay, so we've eliminated test path. We've said we're going to handle it here instead of letting the PowerShell commandlet run. We've created our folder. We'll then call our function we're testing. And then now we fall into a for each loop. And here we're just doing some more of what you've kind of seen before, where I am making sure that the image file name exists. And then I also make sure that the image file name existed in the download list. Remember, one of the things that the get podcast image function does is for each file it downloads, it outputs that name, and we capture those in the variable that we return the values to. Now, here is another variation. I notice we're really just about out of time. I think you guys usually go about an hour, I believe. Mike, let me know if that's incorrect. But so I'll go through this last part fairly quickly. But we're just basically doing another test where what we're going to do is we're going to fake some existing files. So, because remember, one of the things we have to do is to test to see if the file exists or not. Comments are pretty self-explanatory, but I'm going to jump down to the bottom because I want you to see down here what an acceptance test might look like. So here's an acceptance test. You notice the very first thing we do is we call get podcast data. Well, what's up with that? Well, in an acceptance test, we can actually call all of the real functions, because what we're doing with an acceptance test is we want to see what happens in the real world. What happens if I actually call all of the moving pieces I need? Will this actually work? If I combine get podcast data, test path, and get podcast image, are all these pieces really going to work together? So acceptance testing typically occurs with the real finalized code. Oftentimes acceptance testing is done by a set of people different from the developers. I also want you to notice that in the previous unit test, I placed in module scope up here outside the describe block, and then I let it hold multiple describe blocks. But I can also use it self-contained inside of a describe block. So, and the reason you might want to do one versus the other is if you had multiple describe blocks that you all wanted to be in the same module scope, you could put module scope on the outside and then run your multiple describes. On the other hand, if you've got a describe block and you only, as part of that describe block, want to test a piece of the code, you don't want to test all of it as part of the module, then you could simply have in module scope within the describe and just isolate that piece that needs to be in the module. So here I have calling the data. And here I demonstrate some really dynamic tests. What I've done is I've created a hash table, and I've said, with this particular set of tests, there's actually a couple of things I need to test. First, I need to test calling it as a parameter and passing in RSS data as a pipeline. But the other parameter that is part of this function is where do I download the files to? With the unit tests, I overrode that and said, don't test using the default. Here it is. You probably didn't see this. I'll scroll over here to the right. I said on both of these, use the output path folder of test drive folder. So I overrode the default. So basically with the unit test, I was unable to test the default path. So that's what I'm doing down here in the acceptance tests, which is another good reason to have acceptance tests, so that I can actually test using the default output path. So basically what I'm going to do is I'm going to loop through each one of these 4 tests: default parameter, default pipeline, non-default parameter, non-default pipeline, and I'm going to see, I'm going to get the value piece of the hash table and put it as the folder name, and then I'm going to see what images I might already have out there. And we'll be using this in just a second, but I have to know what images are already existing to make sure that I don't download some that already exist. So I then simply switch on the name to see which version of the function I should call. This is similar to what you just saw. Now, one of the things I'd like to do is to use the words default or non-default in parameter or pipeline in some of my context blocks. Well, to do that, I'll need to split them up so that I can separate them on the space. So here, I'm doing the split based on space, and just for the array that split returns, I'm getting the first element, which is 0, and the second element, which is 1. I don't know why people who wrote the basis for this start counting at 0. I guess they didn't take basic math in kindergarten. But anyway, so we have 0 and 1. And then you can see my context block, acceptance test, get podcast image, and then I tell it whether I'm using the pipeline or the parameter, and then I tell it whether I'm going to the default or non-default folder. And then these tests are very similar to what you just saw with the unit tests. I basically make sure the file name exists. I make sure that the downloaded images that already exist, the images names that were downloaded didn't exist in the images that already existed out on my disk. And then here I'm doing something that is kind of optional. What I've said was for each image that you just downloaded, remove it from the disk. Now, this is because you may want to isolate this for your next run. This isn't always done, though, with acceptance tests. Sometimes with acceptance tests, your acceptance testers want to see the files that you downloaded. So be sure to kind of check your requirements, talk to those testers to see if you should be cleaning up after yourself or if they want those images left out there for them to see. So let me go run this real quick. We'll get close to wrapping this up. What I want to do is run this. Now, I want to show you out here to the right, we have --tag unit and --tag acceptance. If I run either one of these lines, it's only going to, even though I'm running the test for the whole file, it will only run the describe blocks that have the tag unit assigned to it or have the tag acceptance. But if I want to run all of them, I'll just run the tests file itself, and that's actually going to execute both of them. Now this is going to take just a second to run because it actually has to go to the internet. It's going to download these images. And what did I do? I must have hit the wrong file. Oh, yeah, I bet I did. So let's go try this one more time. So now you can see that it's actually downloading files. And it's going to have 15 of these little files to download. So this will take just a second because I have really, really bad internet. One of the joys of living out in the country like I do is my internet's a whopping 6 megabits. So now it's just downloaded all the files, and you can see in the background the image should exist in the download files. And so, of course, this makes sense because this is the unit test piece of this, and those files should not have existed already. So it's now telling me that these files didn't exist. And so now here we go with describing the podcast image acceptance tests in which we're really writing to the file. And we'll scroll back up here in just a second. As soon as this gets done, you can see all the output. So if you have questions, go ahead and get them ready. We'll be wrapping up here in just a second. We're kind of in the closing pieces here. Promise not to keep you too much longer. There we go. So should have downloaded. So as you can see, it's downloaded several images. And so there we go. Our test completed in 85.1 seconds. 200 passed. None failed, none skipped, and so forth. So Very, very cool. If I scroll back up, you can see here the first test, podcast 1 should have a property of title and so forth. Let me scroll down. That was from the previous test that I didn't mean to run. Yeah. Okay. So you can see here all of the tests pass, but I wanted to show you one other thing here, and that's what these 4 right host lines do. This talks about the scoping and how the scoping interacts with in-module scope. And this is a very important thing to understand. Here I have my $ here variable, and it has a value. Then I have a variable called buzzkill, which I stuck the value JCD in. And then I display these again. Now the second time, here is empty, but buzzkill holds JCD. Why is that? Well, let me come back over here. And whoops, sorry, wrong file. Podcast image tests. Here you can see where I have my right hosts, and then I fall into module scope, and I have right hosts again. Well, why is this different from here? Well, remember, in module scope shifts the scope from your script into the module. So any variables you declare outside of in-module scope are no longer visible once you hit in-module scope. The exception is anything that is declared global. Now, I know global is typically considered a bad practice. Not a really good idea to create global variables and functions. However, in this particular case, it is the only way to reuse a variable declared outside of in-module scope to code inside of module scope. And that's why when I printed out the buzzkill here and then again here, that's why it displayed the value, is because I used in the global keyword in front of it. Again, if you had a function that you declared outside, but you wanted to use it inside of in-module scope, you would have to put global in the front of the function. So that's why that little code exists. It's really important to understand how in-module scope works. So be aware of that. And I guess with that, we've thrown a lot at you. If you want to learn more, feel free to email me. You can go see it's like a 4-hour version of this course out on Pluralsight. It should be up any day now. Let's actually go check to see. Here is my Pluralsight page. And let me just do a quick refresh on this. And we'll see. They're supposed to put it out like any day this week. So there we go. Nope, not yet. But I do have some other courses you might be interested in. I've got a 6-hour beginning PowerShell scripting for developers course that goes deep into PowerShell. It talks about everything from the real basics, which I'm sure you guys are probably aware of, all the way into writing modules, how security works, everything you could ever want to know about writing PowerShell modules, except of course for Pester testing, which is covered in the new video that's about to come out. I got a few others out here on PowerShell and SQL Server and whatnot, so lots of good stuff out here. And again, just send me an email to free@arcanetc.com, and you don't have to pay for this, just 30-day free trial, or if you've already got Pluralsight, great. So, phew, we covered a lot this evening, so only went a few minutes over, and I guess I'll turn it back over to Mike to see if he wants to unmute folks, see if we have any questions. Don't see anything in the conversation window.
Yeah, if we have any questions, feel free to unmute if you'd like and ask them or type them in the chat. Yeah, the hash table stuff you were showing there briefly, Robert. I was actually working on some of that while you were talking. I was working on a the test I was telling you about before we got started. And what I did, I actually took the Pester test for the environments I'm going to be upgrading later this week. I had like 164 lines of code, and I had things hard-coded in it like port numbers. I had like 4 context blocks, and each context block was for a separate environment. What I did, I reduced it down to a single context blocks. So instead of like, I had like 24 it blocks, and now I only have 6 it blocks, and I used an array of hash tables, and each hash table is for an environment, so it's much easier to see in the hash table, the port numbers and the name of the environment and so on. And now my code is, so I've got 72 lines of code instead of 164 lines of code.
Yeah, I love the ability to create dynamic tests like that. It's really, really powerful. I also mentioned too, and your chiming in, Mike, reminded me. Now we've shown this Pester in the context of testing a module, but you don't have to test an entire module. If you just have a single script, but it's one that you rely on heavily, you can write a Pester test for just that script. You can also use it to test your environment. So, and I kind of alluded to this earlier, but I just want to make it clear. Let's say you have well, as Mike mentioned, you're transitioning into a new SQL server. So you're setting up test environments, and you're setting up production environments and so forth, and you want to ensure that it's configured correctly. Well, you could write a Pester test to not test other PowerShell code, but to test your environment. Part of the video course I have is testing a SQL Server module, and I show examples of how you can connect a SQL Server, so how you could query, are these, do I have the required tables and whatnot. You could also use a lot of the built-in functionality of PowerShell to make sure ports and services are correctly running, and ones that shouldn't be running are not. Let's see. If anybody wants the sample codes, email me, either address, arcane@arcanetc, are free. I'll be glad to zip up all the demos that we saw and send them to you. I see a question from David. I see in the about should help there is an operator for be greater than. Is there one for greater than or equal to? I don't remember off the top of my head. Let's see. If we go to actually the PowerShell folder, I've got a sample of where I downloaded. Oh, it should be here in the GitHub site. So they have some really good documentation in here. Pester Wiki.
I don't think there's one for that specifically, but what I've done in that scenario myself is I'll actually do the comparison before I say should. So I'll say, I'll do like a normal PowerShell comparison, and then I'll say like it should be true or it should be false.
Right. Yeah, that's a good point, and I didn't really show an example of that tonight, but you can actually construct a fairly complex PowerShell expression such as, is A, G, dash G, E, B, and then put all that in parentheses and pass that into the should be true or should be false test. And so if you look here under the command reference, if you go to the GitHub site under the Pester Wiki, it has a really, really good wiki in which we go into the command reference, and it has each command, and under should, I believe it lists the various variations. So we've got negative assertions, should be true, should not be false, be exactly, there's a be greater than, be less than, we have be like, so you can see all of the different be's that are out here. So go ahead and take a look at this. Like Mike said, doesn't seem to be a be greater than or equal to, but you can accomplish that in the method he described. And so looks like Mike pasted something into the window.
That'll give you all the should operators by querying the latest version of Pester on your machine, because occasionally there's some that are undocumented. Like I'm not sure that should throw is documented.
I don't remember.
So
yeah, it doesn't appear to be, but there is a should throw that says should throw an error. I think, oh, here it is, right here, should throw.
And then
So
there's another one
this
called
just tests to make sure an error got thrown.
Should be of type. I think some of these were added real recently.
Yeah, always go, like Mike said, and this little thing he created makes it really, really nice to just easily go out and query the various pieces, parts that are in the PowerShell Pester module. Also be aware that they're, from what I understand, very close to releasing version 4 of Pester. So I don't know how soon that's going to be. That's just that's from what I hear. So, all right. So, any other questions? Looks like, see, any plans to present on the operational validation framework or using Pester for environment or server validation. I've not used the operational validation framework before, so that's a new one for me. Pester for testing the environment. That sounds like a good set of blog posts I'll have to get into or whatnot, but the construction of it would be pretty similar to what we've described. You'll just say, it, should have port open, 1, 2, 3, and then you'll have the appropriate Pester commandlet to test to see if the port's open, and then pipe that into a should. So it should be pretty straightforward to construct. Other questions? All right, I don't hear any questions. I don't see any in the chat window. So, Mike, if there's nothing else, I just want to thank everybody for attending tonight. Or if you're watching this video later on down the road, I want to thank you for taking the time to watch. Appreciate spending a little over an hour with me. And again, if you're watching this later, still feel free to email me to get your 30-day code or get code samples, whichever, or both. I'm easy. All right, Mike, I'll turn it over to you to wrap things up.
Thank you, Robert. That was a really great session, and this is something I've actually been looking forward to, this particular presentation.
Agreed.
Awesome.
Very good presentation. Thank you, Robert.
Thank you.
Okay, well, is there anything else you wanted to cover, Ron? If not, we'll wrap this up for tonight, and let me take a quick look and see who we have next month. I know we have a presenter already lined up.
All right, and yeah, while you're looking, I'm good. I don't think there's anything else.
Yeah, and as far as the operational validational framework and also operational readiness test, if you can go out to my blog, mikefrobbins.com, and I've got some blogs on that sort of stuff, and that's actually what I was referencing to Robert earlier, is I'm doing some environment upgrades, moving VMs from an old Hyper-V host to new ones, and instead of, we would all check things manually. It's like I would check this, that, and the other to make sure this environment's up when I'm finished. Instead of doing that manually, I'll just go ahead and write some operational validation test so I can run it this time. But not only can I run it this time, but in the future, I can just use the same test over and over, and I can even give it to a coworker of mine. So if he ever works with the environment, he can run this test. Or if somebody, although we have monitoring, sometimes if you have a major issue and you get 50,000 emails, if I want to check and make sure this particular system is up, there's several different moving parts and servers and so on, like SQL and application servers and reporting servers and all this. I can check services and check ports, and I do a dumb test on SQL Server that I query the list of databases from the master database, and I make sure that it returns a database with the name of master. which is pretty dumb, but you'd be surprised. Sometimes you can have a SQL server that the SQL service is running. It's listening on port 1433, but it still won't answer queries. So, like I said, it's just a cheap, dumb test to make sure, hey, yes, I am answering queries. So next month, our meeting is going to be on July 12th, and we've actually got Mike Fowl, he's a SQL Server guy also. I don't have his topic yet, but I'm sure it'll be something SQL related. He's presented at a lot of SQL Saturdays on PowerShell, and he's also done several different pre-cons at different events. He, if I remember correctly, he's from Denver.
Yeah, he's a good presenter. I think you guys will really enjoy him. Great guy.
Okay, well, guys, we'll look forward to seeing you next month. And we did record this meeting, so normally we try to post it the Tuesday following the meeting, so it'll be next Tuesday. I should see it up on the user group website. Have a great night.
Thanks, everybody.
Thanks,
Have a good night. Thanks for coming.